Okay, so having looked at the Earth's interior, now let's look a little bit about the face of the Earth, what's on the surface of the Earth. So the two main subdivisions of the Earth's surface are going to be the ocean basins and the continents. Okay, one of the main differences between them is their elevation difference, which results from differences in both densities and thicknesses. For ocean basins, the average depth to seafloor bottom is about 3.8 kilometers below sea level, and the average crust under ocean basins is of 7 kilometers, all right? So that we went through in the last slide. The average density of the crust is 3 grams per centimeter cubed in the ocean areas, in the oceanic crust, resembling mantle densities, which are pretty comparable to that. And the compositions of these oceanic crust are going to be similar in terms of a little bit more similar to the continental crust than those of the mantle. All right, so that's why they're still considered crust themselves, but they do differ. For continents, the average elevation is going to be 0.8 kilometers above sea level, for the most part being flat features, but you do have obviously mountain ranges that we see throughout, which is what brings up the average elevation above sea level. The continental crust itself has an average thickness of 35 kilometers in depth, but I have told you before in the past few slides that it does reach up to 7 kilometers in certain areas where you have high mountains. And the average density of the continental crust is only 2.7 grams per centimeter cube, so it's definitely a little bit less dense than the oceanic crust. So the less dense continental crust is more buoyant, less dense, than the thinner and denser oceanic crust, and hence this continental crust kind of floats at a higher level on top of the more deformable mantle rocks than does the oceanic crust. Okay, so the same way that a lighter cargo ship, for example, will flow easier and faster through the water than a full and heavy cargo ship. So again, in this analogy, the water is going to be the mantle, and then the lighter cargo ship is going to be the continental crust, and the heavier cargo ship is going to be the oceanic crust. So the continental crust will flow easier on top of the mantle than the oceanic crust will, because it's a little bit heavier, a little bit denser. So again, remember, chemical composition of the crust is like the continental and the oceanic crust chemical composition somewhat resembles one another, but it's still different, but not yet as different as to make it closer to the mantle chemical composition, okay? So now we're going to look at the oceans themselves. So if all of the water was drained from the oceans, a great variety of features could be seen at the bottom of the seafloor. Among those features we have seamounts, volcano chains, deep canyons and plateaus, probably nearly as diverse as we see them in the continents. A bunch of different features that we see in the continents would probably also appear in the ocean bottom, or do appear in the ocean bottom, but they're not visible to us because of all the water that's on top of it. So we didn't really know too much about the ocean and the seafloor itself until about the 1940s and 1950s. With the help of sonar technology that was developed, and this technology was developed partly because of World War II reasons, it wasn't until then that we started to know and to comprehend the complexity of the seafloor itself. We were able to map the continental margins and the ocean basin features. So it was not until then that we started developing that bathymetry study. So I mentioned two things. So I mentioned continental margins and ocean basin features. So these are two parts that are officially part of the oceans, but differ pretty greatly. The continental margins are made up of continental crust, and they sit, although they're covered by water, I should say, they sit on a different type of crust, and they tend to be higher elevation than the rest of the ocean basin or the ocean floor. So the continental margins are composed of three different parts. The first one is going to be the shelf. And I should mention, I guess, that the continental margin, as the name suggests, are the closest areas to the continents. But again, they're subdivided by three pieces. The first one being the shelf, which is a gentle sloping kind of platform, and it varies with extent depending on the geographic location. So, for example, the Gulf of Mexico shelf has a much larger area or extent than the Pacific coast shelf. The slope is the following part of the continental margin, and it's a relatively steep drop-off that extends from the outer edge of the continental shelf, which we call a shelf break, to the floor of the deep ocean. So if we use this as the dividing line in terms of considering continental versus oceanic crusts and true continents, about 40% of the Earth is occupied by continents and 60% by ocean basins, rather than the 29 and 71% that we call right now. So if you include, again, that continental margin as being part of the continent, continents really do occupy about 60% of the Earth rather than 40% of the Earth rather than the 29 that we call right now. All right, so after the continental slope, after the margin slope, I suppose, comes the margin rise. So the rise consists of this wedge of sediments that have moved downslope, so down from the shelf throughout the slope and move downwards until they hit the ocean floor. So this rise is composed just of those sediments, and they don't necessarily exist everywhere. Sometimes you don't have as much sediment buildup, so you don't have this envelope that makes up the rise itself. So it is hard to see them in areas where you have, for example, deep ocean trenches, like in the South America Pacific coast, and I'll show you some images later for that. But again, in continental margin areas that are still within the ocean, meaning below sea level, we have shelf as the topmost part, a gentle sloping platform, the slope, which is a much steeper area that drops off all the sediment, and then the rise, which doesn't always appear, but it does in certain scenarios. Okay, so those were the main features from the continental margin: shelf, slope, and rise. From the ocean basins, which are really the widest part of our surface on the planet, we have a few different features that we find all kind of spread throughout, but they do have a characteristic and different properties that make them be where they are. So most oceanic basins are made up of very flat features named abyssal plains. All right, very flat features, abyssal plains. But they also have other features that are incredibly deep depressions, for example, which we call the deep ocean trenches that I was referring to earlier. And they're usually located near mountain building events. So there's that same example that I gave you before. There's a deep ocean trench that pretty much follows the continental margin, coastline, if you would, of the South America Pacific. So that is going to be called the Peru-Chile Trench, and it is just off the continental margin from South America where the Andes are located. Other trenches parallel to volcanic island arcs, for example, exist, such as the Aleutian Trench up in Alaska, so that island arc that exists where we have a lot of volcanism, for example, sits just a little bit north of where the Aleutian Deep Ocean Trench lies. Another feature that we have in the ocean basins are seamounts. They're kind of dot the seafloor, if you would, as we see them in bathymetry as well. So they are submerged and sometimes eroded volcanoes, basically, and many times they appear as chains as well. So just like Hawaii, think of Hawaii, that it appears in a sort of chain-like trend. We have the seamounts chains as well. So a little bit northwest of Hawaii, there's a big chain that is associated with the same hotspot that is causing Hawaii's volcanism right now, which is called the Emperor Seamounts. Another feature from the ocean basins that we have are the mid-ocean ridges, and that's probably one of the most prominent features that we see in the ocean floor. These mid-ocean ridges are broad elevated features that form a continuous belt around the globe. It's sometimes hard to see how it's connected, this belt, but in certain areas it's more prominent than in others. For example, in the mid-Atlantic ocean ridge, or how it expresses itself there. So this ridge is composed of layers upon layers of new igneous rock that are being erupted basically from deep within the mantle and are rising towards the crust. And once they reach the crust, they erupt and they spread from one another. So there's layer upon layer that is being subsided by the next layer that's coming into place. So you'll see that phenomena taking place in the next chapter when we cover plate tectonics. We'll also talk about mid-ocean ridges as part of this. But basically it is at mid-ocean ridges where we get new crust being made continually, and this crust is being made by the lighter elements that are rising up to the surface, making up new crust. So figure 1.24 of your book is great to see all of these oceanic features that I just talked about. So starting from those in the continental margin, the shelf, the slope, and the rise, going to all of those in the ocean basins, such as the abyssal plains, deep ocean trenches, mid-ocean ridges, and seamounts. So to point a few out, here is that deep ocean trench that I was referring to, the Peru-Chile trench, and here is the Aleutian Trench that I was referring to as well, just south of the Alaskan volcanic islands there. Here are the seamounts that I was referring to. It's kind of hard to see them in this image. Oh, never mind, they're right here. We can see them on the other part of the map. They're the Emperor Seamounts. Here is the mid-ocean ridge that I was referring to earlier, and it's very clear here. Not so much everywhere else, but it's still there. So this picture in your book is very good, or this figure I should say, in your book is very good to be able to differentiate between all these ocean features. I strongly recommend that you look at it and sort of become familiar with the different features you'll be looking at for the rest of the course.